So welcome to lesson 4.4. We're going to be dividing powers today. And by the way, if you've been noticing this is a problem with the font. It's 3 squared times 3 to the negative fifth equals 3 to the negative third, which equals 1 over 3 to the third equals 1/27th. That's been there for all the lessons. Okay. So we've been doing this, right? X cubed times x to the fourth times x is x to the eighth, right? You're adding exponents, you're multiplying all that, right? And the reason that is because x times x times x is x cubed, and then x, that you're multiplying that times x times x times x times x, and you're multiplying that times x, that's x to the eighth. You're adding the exponents. What's the coefficients here, right? We have a 7 and a negative 1 are coefficients. There's a question on the test about that. 7 times negative 1 is negative 7. We multiply the coefficients. Now we do y to the fifth times y, which is y to the sixth, right? You have to add the exponents. All right. Yesterday we learned how to cancel that as long as we assume x isn't 0. And we have nothing up top, so we put a 1, and then we have a 5 on the bottom, 1/5. The 9 cancels with the 45 and becomes a 5. The x's cancel out, and we have 5 over y. All right, so now we're going to be dividing powers. Now, if we have x to the fourth over x, I'm looking at the green one, right? You can cancel those x's, and look what you have left, x cubed in the numerator. If you have x over x fourth, the x's cancel. Now we have x cubed in the denominator. And if you have x over x, right, we talked about that being 1 yesterday. But interestingly, that is also x to the 0. And we will see, you'll finally see why everything to the 0 power equals 1. So we're assuming, by the way, the same rules, we can't have 0 in the denominator as yesterday. So we can cancel the terms with the same base, right? So if we have x cubed over x squared, we can cancel those x's. And then we could cancel these x's. We have 1x up top. Or we could cancel those x's, and we could cancel those x's, and we have 1x on the bottom, or 1 over x. So what's this, right? It's x to the fifth over x squared. All right, so those cancel, and what do you get? You get x cubed. Next. So we're going to treat this, right? We're simplifying, treating that 2 just like it is an x. So there's 8 2's up top and 3 2's on the bottom. Did I make enough? Yes, I did. And, right, we get 2 to the fifth. Here we have y over y times y times y. Those cancel, and you get 1 over y squared. These 9's you treat just like the x or y's. 9 times 9 over 9 times 9 times 9 times 9 times 9. And you get 1 over 9 cubed. Okay. Now, hopefully you're seeing maybe a shortcut here, right? When we were multiplying powers, we added the exponents. Here we are subtracting the exponents, right? 8 minus 3 is 5, 5 minus 2 is 3. But there is a problem with that shortcut on the bottom ones. Look, you have 1 minus 3, right? Well, what's 1 minus 3? 1 minus 3 is not 2, right? And this is why negative exponents make reciprocals, because 1 minus 3 would be negative 2. And so that makes the correct answer, 1 over y squared. 2 minus 5 equals 9 to the negative third power. Oh, that's the same as what we got, 1 over 9 cubed. That's why negative exponents make reciprocals, because of this subtraction right here. All right, so we could write it all out, or we could do 9 minus 2. All right, so x to the 7th. All right, so now, what is this? So we're going to do this a different way. We're going to cancel the 2 and put a 7 there. Here we're going to cancel the 10, right? And then we're going to have 3 extra there, but we have 3 extra on the bottom. So it's 1 over 7 cubed. Instead of doing 10 minus 13 like this way, which some teachers do it that way, we're going to just cancel this 10, right? There's 10 of them there. That cancels 10 of these, and there's 3 left, 1 over 7 cubed. We canceled this 2 and canceled 2 of these 9 and had 7 left. Right? So, right, if you have 5 minus 5, right, how many extras do you have? Right, you got nothing, right? They all cancel, you get x to the 0. This is why everything to the 0 power equals 1. Because if you have the same amount of anything, right, you could have x to the 7th over x to the 7th, that's always going to all cancel, and you're going to get something to the 0 power. And that's always going to be, when you have the same thing top and bottom in a fraction, that's one whole, as long as the denominator there is not 0. Okay, now when you see how many times larger is 7 to the 5th than 7 cubed, this is a division problem. And right, it has the word times in it, yet it's a division problem. The first thing goes up top, or the bigger number, really, but in this case, it is the bigger number, because you're seeing how many times larger 7 to the 5th is than 7 cubed. Well, it's the same thing as the others. You canceled 3 of those, there's 2. Well, it's 7 squared, or 49 times bigger. So let's understand this. 7 cubed times what equals 7 to the 5th? Well, what has to go in there? 7 squared, right? So this one, the answer is 49, or 7 squared, bigger than 7 cubed. Let's do that again. So 10 to the 5th divided by 10 squared, those cancel, and you get this, you get 10 cubed. How many times larger is 10 cubed than 10 squared? Well, 10 squared times blank equals 10 to the 5th. Well, it's 10 cubed, and what is 10 cubed? Another way to say this, either would be correct, is 1,000. It's 1,000 times bigger, right? It's not a little bit bigger, it's much bigger, because of all those 5 minus 2 is 3. Okay, now we're going to start mixing things together. So this first problem, you have a mix of multiplication of powers and division of powers. My recommendation is do the multiplying first. So 5 cubed times 5 to the 6th, right? We're adding the exponents there and getting 5 to the 9th. Now we're going to do what we've been doing. We're going to cancel. This 2 cancels and becomes, just cancels, sorry. And this becomes a 7, and this becomes 5 to the 7th. Again, I would rewrite the x to the 13th. When you multiply powers, you add the exponents and get x to the 15th. Those cancel, and we have 2 extra, 1 over x squared, right? The x squared is in the denominator. Here, y to the 5th times y squared, y to the 7th, y to the 7th over y to the 7th equals y to the 0 equals 1. Okay. Now look at this one. We also could have written that as x to the negative 2nd, right? Because negative exponents make reciprocals. 13 minus 15 is negative 2. Okay, now we're going to put coefficients here. Remember, the coefficients are 15 and 5. They get actually divided. So you do 15, right? 5 divided by 5 is 1. 15 divided by 5 is 3. Then we're going to cancel the powers. X squared goes away, and that becomes x to the 7th. There's nothing left in the denominator, and it becomes 3x to the 7th. You do the coefficient powers separately, and then you bring it together. So negative 36 divided by 9. 9 divided by 9 is 1. Negative 36 divided by 9, negative 4. All this y to the 6th cancels, and there's 1 y left on the bottom. That's negative 4 over y. Now these look hard, but they're not really. The negative 7 goes away because it goes into 42 6 positive times, right? 2 negatives make a positive. Let's use colors just to be clearer. X cubed goes away, and we have 2 extra x's left in the numerator. And y, that 1 y goes away, and we have 3 extra y's left in the denominator. So then the answer, what do we have left? We have x squared in the numerator, and we have 6 y cubed in the denominator. And the answer is x squared over 6y cubed. You take any numbers and put in for x, y, and x and y and do all the math with a calculator, you'll get the same answer as x squared over 6y cubed. We just consider that simpler. Okay, so same amounts cancel each other out. 2, right? There's 2 extra y's in the numerator. Everything's gone from the denominator. That's y squared. This you do the same way. All the 2's go away. There's 1 extra 1 there. All these 5 goes away, and there's 1 extra. So this is 2 to the first over 5 to the first. You're not going to leave it that way. The answer is 2/5. These cancel, and there's 2 extra 7's there. That 1 8 cancels. There's 2 there. So this is 7 squared over 8 squared. We could leave it that way because it says simplify, but let's evaluate. So we could leave it that way, but let's evaluate it just for fun. So that's 49 over 64, right? If I evaluate it, that's what I want. Simplified, that's what I want. Right, whiteboards. So we'll do all these. Whiteboards is what we would do if we were in class, but here I want you to solve all these. Right, so the negative exponents stay negative. They don't do any weird stuff, and it's negative 13 squared. Parentheses not optional. You have to put them. Right, you multiply for the numerator, then these all cancel, and you get 17 squared. And since we're simplifying, you can stop there. All right, so I would multiply across the top, and there's a 1 there. Don't forget that. X to the 11th. 5 plus 8 is 13. Those cancel, and you have 2 extra on the bottom, which is 1 over x squared. That's also known as x to the negative second, but we want this one really. Now, coefficients, we're canceling there. All those y's cancel. You got 1 left, right? So 1 on the top, 5y on the bottom. This 6 becomes a 1. 6 goes into 54 9 times. All those x's go. We have 3 x's left on the denominator. All those y go. You have 1 y in the numerator, so you have 9y in the numerator and 1 x cubed or x cubed in the denominator. So this is this. 8. 8 times larger, right? X to the 4th is 8 times larger than x cubed. 8 cubed. I almost said x cubed. Good luck with your homework.